So, finally, this is the last part under differential calculus, stationary points. Find the coordinates of the stationary points on the curve y is equal to 2x to the power 3 minus 3x squared minus 12x plus 4. So, you need to know what a stationary point is. Look at this. You should take note that whenever, let's assume this is our curve. Whenever stationary point, it means where it is turning from, where the curve is turning from. So where the curve is turning from, the dy dx is 0, meaning gradient is 0. Even here, dy dx is 0, right? Where the curve is turning, the dy dx is 0. You should take note of that. So in this case, they have talked about stationary points. Stationary, it means turning point. Same thing. So how do you go about it? So first of all, you need to differentiate this. So you are aware that whenever you're differentiating, you can show that there's letter x, variable x, and the powers must be visible. So since there's x already here, you put 1. Then here where there's no x, you put 4x to the power 0, because x to the power 0 is 1. 1 times 4, you go back to 4. So next step, you need to do this. You can now go ahead and differentiate. Dy dx is equal to 3 times 2 is 6. 3 minus 1, always you minus with a 1, is 2. Then 3 times 2 is 6. Minus 1, it will be just 6 to the power 1, same as 6. Then in this case, 1 times 12, it will be just 12. 1 minus 1, it will be 0. 0 times 4, you see that one? That one will cancel, it will go, it will vanish. So we've been saying whenever there's a constant, a number without letter x with it, when you differentiate, it will be a 0. This is how it becomes a 0. So now, next step, you need to rewrite this. Dy dx is equal to we need to simplify this. X to the power 0 is 1. 1 times 12 or negative 12, it will mean negative 12, right? Now, remember that we are saying whenever they are talking about stationary points, the dy dx is 0. The gradients are zeros, right? So now, it means where there's dy dx here, we put 0. So we write like this. So writing like this, same as if you were to write like that. We haven't changed anything. So since there's a 6, 6, 6, a 6 can go into all these. So better you reduce it. Over 6, over 6, over 6, over 6. It's not always you reduce. It depends. If you are able to, you can do so. So now, we know a 6 and a 6. There you go. Even here. And here, we know it will be 2. It will be 2, right? So we write x squared has remained here, so x squared remained. Then here minus x remained. 6 into 12 is negative 2. 6 into 0 is 0. Then from there, you can use factorization method to know the x values. So now, you know here there's a 1. So you need to look for product, the sum, and the factors. Product, you multiply 1 times negative 2. Sum, just get the middle number, not x. Here there's 1, right? So it's negative 1. Factors, it means look for 2 numbers. When you multiply, you get negative 2. When you add, you get negative 1. So in this case, it will be negative 2 and 1. You can try this. Negative 2 times 1, you get negative 2, the product. And if you do the sum also, you add negative 2 plus 1. Negative 2 plus 1, you get negative 1, right? Negative 2 plus 1, you get negative 1. So these are the real factors, right? So when you multiply these, you get negative 2. When you add, you get negative 1. So these are indeed the factors. So what you have to do, you replace here. You replace here. Don't write this. Instead, write the factors, right? Negative 2 and 1. So you can start with any. This is negative 2. You write negative 2x because you are replacing here. Then another factor is 1. So you write 1x or just x. So it is positive, you write positive x. You see this? Negative 2x plus x. You go back to negative x, right? Or negative 1x, whichever. Then this minus 2, write it the way it is. After that, you need to factorize the first 2 and the last 2. The first 2, if you factorize, x is common. So it was x squared, so x remains here. Here x is already outside. It means negative 2 has remained. You do this. As you are starting the next category, there's a plus here, you write it. What do you have in common? Nothing is common, so 1 is always common, and you rewrite this. So you need to get the same things here. Same. So you say x minus 2 is common, write it as 1. Then here you remained with x plus 1 is equal to 0. You move on. So you write x minus 2 is equal to 0, or x plus 1 is equal to 0. This is what you are supposed to do. So we are still moving. So we have, let us rewrite this. So we write x minus 2 is equal to 0, or x plus 1 is equal to 0. So negative 2 crosses, it will be 0 plus 2, it will change the sign. Then here 2 remains. And here it will be 1 will cross, it will be 0 minus 1. 0 minus 1 is negative. Now these are just the x values. Now a coordinate must have an x value and a y value. X value and a y value. So in this case, we have just found the x values. What about the y values? So you need to go back to the original function. We were given this, remember? We were given this, so we need to replace where there is okay. So we replace where there is x, we put 2, then later on where there is x, we put negative 1. So let's do it. So we have 2, where there is x, we put 2, so it will be 2 to the power 3 minus 3. Then where there is x, also we put the same 2. Then here also you write plus 4. So if you simplify 2 to the power 3, it will mean 8 here. And here 2 to the power 2, it will mean 4. Then this one, you can maybe leave it for now. So next step, 2 times 8 is 16. 2 times 8 is 16. And 3 times 4, it will mean 12. So negative 3 times 4, negative 12. Negative 12 times 2, negative 24. Plus a 4. This is paper 2. You are free to punch. If you punch this one, 16 minus 12 minus 24 plus 4, it will mean negative 16. So y is negative 16. So if we go back to this one, when we replace with a 2, I found in negative 16. So it will mean the coordinate will be 2, comma, negative 16. As you can see, this is the x value, the y value. This is the first stationary point. The second one also will do the same. We need to replace with -1 now. Where there is x, we replace with -1. So we do it. So therefore, y is equal to 2. Where there is x, we put -1. So we write -1 to the power 3 minus 3 -1 squared minus 12 -1 plus 4. So simplify further. -1 to the power 3, it means -1. -1 squared, it means just 1, because -1 times -1. You can rewrite this the way it is for now. Oh, sorry. Okay. So this is what we are doing. We are just replacing. Where there's x here, we are putting, where there's x, we are putting -1, right? Throughout. -1, -1, -1. This is what we are from doing. -1, -1, -1. So -1 to the power 3 is -1. -1 squared, it means -1 times -1 is 1. Then we write this. So in the next step, 2 times -1, -2, -3 times 1, -3, -12 times -1 plus 12, then this one plus 4. Still, you can punch this if you want. If you want, you can punch this. Since this is paper 2, you are free to do that. Do it with me. Let's see. What answer are you getting? What answer are you getting? -2 minus 3 plus 12 plus. What answer are you getting? This should be 11. That is 11, right? That is positive 11. So you write it. So as you can see, when we replace with -1, the y value was 11. So this one is our another stationary point. Stationary point, like we said earlier, where the curve is turning. Where the curve is turning is what we call the stationary point. And wherever the curve is turning, the gradient is a 0. The gradient is a 0. So you can pause this and go through over and over so that you benefit.